Dr. Owenbrink with Appalachian Wellness, reviewing the neural pathways and neurotransmitters involved in the disease of addiction.
The neural pathways involved in addiction are very interesting. They're very complicated. They also form in withdrawal. These circuits, prior pathways, can be thought of as circuits ready to be re-energized at a moment's notice. When folks relapse, they don't start with their addictive disease at the level of when they first became addicted. They typically relapse to a degree that was as great as or greater than what they were using when they had stopped using, even if it was decades ago. These neural circuits still exist. Think of a superhighway that was built, used for a while, and then for whatever reason falls into disuse. There may be very little traffic going on it, but there's many lanes available to carry a whole lot of traffic in the future should that become necessary. Addiction does change the brain structure and function. It causes impaired decision-making, impulsivity, especially in the prefrontal cortex, which has changes in addiction. This compulsivity in the prefrontal cortex causes changes leading to drug-seeking behaviors, cravings, habit formation, relapse triggers, stress dysregulation, and withdrawal, which happens more in the primitive brain areas. The prefrontal cortex can be thought of as a braking system for impulsivity and compulsivity. Addiction involves numerous structural changes in the brain, such as those with the dopamine 2 allele and the locus coeruleus and other areas of the brain, and those with addictive diseases. The mesolimbic system pathways are critical to the neurobiology of addiction. They're located in the brainstem, essential for our basic survival. The ventral tegmental area is located at the front of the mesolimbic center. The VTA projects to the nucleus accumbens, the reward center of the brain. The main mesolimbic neurotransmitter, dopamine, is the feel-good neurotransmitter. Dopamine is released when we engage in activities that help further our survival and the survival of the human species, which of course involves sex. This helps ensure our survival as a species. Things that happen in this part of the brain, this primitive part of the brain, feel that good. They really drive us forward. All addictive drugs and activities release dopamine into the nucleus accumbens. Stimulant-type drugs release more than other classes of drugs. Dopamine is associated with pleasure-seeking and drug-seeking craving activities. GABA and glutamate are also involved. These are other neurotransmitters involved in pleasure-seeking. They're more involved with alcohol and benzodiazepines. Dopamine is also involved in drug craving and dopamine deficiency with withdrawal. Natural cravings like food, water, and sex lessen with time and with satiation. When you've had enough, you've had enough. Dopamine activity increases with habituation. Once satisfied, those are enough. That's a natural craving. With addiction, it's another matter. This is an unnatural desire. Tolerance happens as people need to keep increasing the dose and frequency of their drug of choice to maintain the pleasurable effect of the amount of dopamine, which wears off after time and continued exposure to drugs. This amount of dopamine is higher than we can achieve normally without this excessive unnatural stimulation. So instead of having enough and being satiated, we become tolerant and we need more and more, higher doses more frequently. Tolerance drives the drug craving and compulsion to use, driving the addictive process forward. As addiction progresses, these cravings, compulsion, gradually replace the pleasure-seeking impulsive use. This is worsened with drugs such as opiates that have severe withdrawal symptoms in addition to craving. Craving as an attempt to avoid or relieve unpleasant symptoms. So addiction starts with pleasure-seeking and ends up in a trap of using to relieve craving. Eventually, the relief of craving becomes its own form of pleasure. As drug use for addictive activity escalates, the involvement of various brain regions associated with our emotional state also increases. The brain region most often associated with our emotional state is the extended amygdala, part of the limbic system, where our emotional center of live or is located. Interestingly, the olfactory bulb is located right next to the amygdala. Scents and smells often have a strong impact on our emotional state for this reason. Scientists think this brain region plays an important role in addiction because of its association with emotions and stress. The amygdala is involved in processing emotions and emotional memory. When the brain forms these memories, it stores the memory of the event along with the emotions that accompanied the memory. The memory of engaging in the addiction is stored with a pleasant emotional state, a positive emotional memory. Thus, the pleasing memories of engaging with an addiction can lead to the repeating these behaviors more and more often as the habit forms. Memory has another role in the development of addiction called cue anticipation. Cue anticipation refers to environmental cues that can initiate or elevate cravings. Cravings then often lead to relapse. This sort of thing could be thought of as an alcoholic who hears the sound of ice cubes clicking into a glass and liquor being poured over it will trigger their craving for a drink. For this reason, these cues are often called relapse triggers. These environmental cues or relapse triggers could be anything associated with the addiction. The brain may also form an association between unpleasant emotions and a memory, forming a bad or negative memory. This negative emotional memory of anxiety becomes associated with the physical signs of withdrawal. As withdrawal begins, the symptoms trigger an unpleasant emotional memory. This increases the negative experience of withdrawal, acting as a feed-forward or amplification loop within the neural circuitry. Withdrawal avoidance via returning to the addiction often becomes the cornerstone of addiction in the later stages. Thus, in the early stages of addiction, the pleasurable experience of the drug motivates repetition of that behavior, impulsivity. In the later stages, compulsive relief of withdrawal symptoms becomes a predominant driver. Physical and/or emotional discomfort is avoided as much as possible. This avoidance causes pleasure. This pleasurable relief from withdrawal symptoms continues to motivate the repetition of that behavior. Addiction has been described as dancing with a 800-pound gorilla. It's exciting at first, impulsive, then it's a habit you do, compulsive, and finally you're exhausted, but you're not done dancing until the gorilla is done dancing. Stress and the role of the hypothalamus. The hypothalamus regulates body temperature, hunger, thirst, sleep, and our response to stress. The hypothalamus signals the pituitary gland to release hormones to the endocrine system, which acts on different parts of the body, not just within the brain as neurotransmitters do. Think of the fight or flight of the autonomic sympathetic nervous system. When you have a tiger in front of you, no bars between you, your heart rate increases, your respirations increase, your blood pressure goes up, and you're ready to boogie out of there. These hormones can also act as neuromodulators within the brain, like a neurotransmitter acts. A medical intuitive, somebody gifted with a sixth sense regarding disease and healing, referred to the hypothalamus as the location of our soul. Stress is a major trigger for relapse. Relapse is a bigger problem than withdrawal for addiction patients. Stress and psychostimulants cross-react with each other, promoting relapse. Psychostimulants, amphetamines, cocaine, methamphetamine, are much more difficult to get off of than other addictive drugs due to this cross-reactivity at the neurotransmitter level. Stress, creating an unfortunate cycle. Efforts to stop using cause stress. Stress triggers a release of the stress hormones from the hypothalamus. Dopamine and serotonin activity in the nucleus accumbens actually decrease with this stress early in recovery. These calming neurotransmitters normally would help reduce the stress. This is a disruption of the normal stress response that occurs with addiction and withdrawal. The dopamine and serotonin neurotransmitters should be increasing to help cope with the stress, but in reality, they decrease, especially with the psychostimulant abuse. Stress triggers addictive behavior, use. Thus, withdrawal causes stress, which can trigger more addictive use, which causes stress to the addict who is unable to stop using the drugs, and a vicious cycle in which the normal calming or breaking serotonin and dopamine activity from the nucleus accumbens is lost. Recovery is the process of breaking this cycle. It takes a lot of motivation. Medications can help, but recovery still requires effort. The brain is very adaptable. It learns. That's what it was designed to do, to learn. Recovery is a process of learning. Learning involves forming new circuits and pathways in the brain. Many recovering addicts testify that the first step effort at recovery is much easier than recovery after numerous slips or relapses. The first is a gift. It's progressively harder to recover after the first attempt. This is one of the spiritual axioms of recovery. Related brain areas and the neurotransmitters and their functions. The negative emotional memory in the amygdala is associated with drug withdrawal. The positive emotional memory in the amygdala is associated with drug cues. Hypothalamic and nucleus accumbens, serotonin, calming, and dopamine feel-good disruption occur to stress or dysregulation. The pleasurable relief from withdrawal symptoms occurs by resuming drug use or addictive activities, reduce stress, and soothe the hypothalamus. Opiates inhibit the firing of neurons in the locus coeruleus. When opiate consumption is stopped, the increased activity of the locus coeruleus contributes to the symptoms of opiate withdrawal. An alpha-2 adrenoceptor agonist called clonidine is used to counteract this withdrawal effect by decreasing adrenergic neurotransmission from the locus coeruleus. Remember, alcoholics and addicts have altered dopamine 2 alleles in the locus coeruleus part of the brain.